Hey guys, so this is an extra examples video. So I have a lesson video where I did a bunch of examples of graphing rational functions. Sometimes people like to see a few more examples. So I have two more example types that I'm going to run through here. Of course, if you guys need more, you're always welcome to talk to me about that. Leave a comment or send me an email or whatever, and I'm more than happy to help you out with that. Okay, so let's just jump right into the two examples. You can fast forward to one if you wanted to see that one. Okay, so starting with the first one. Okay, so I need to graph this rational function, and I'm going to go through all the same steps that I went through in the video. So something that might be helpful, like something that we'll just kind of consider, we'll decide later on if it would actually be useful, would be to multiply everything out. Sometimes that's useful, sometimes that's not. So let's just keep an open mind to it. For now, we need to find our asymptotes. So to find the vertical asymptotes, well, the nice thing about how this function is written, if I set the denominator equal to 0, well, this is actually already factored for me, so I can pretty easily see that my asymptotes are 1 and -3. Now, the trickier thing here will be to determine what is the degree of the top and the bottom. And so really the number of factors that you have are going to determine the degree. So I have two factors here. So this is degree 2. And this one is also degree 2. So there's two factors here. But you might be saying to yourself, you know, to figure out the horizontal asymptote, it would be a lot easier for me if I just multiplied all this stuff out. So why don't we just take a second to multiply everything out just so that we have that reference. So let's see. The top would be x squared plus 4x plus 4. And the bottom would be x squared plus 2x minus 3. Okay, so now that I can see these are both degree 2 polynomials, I can say that, okay, just take the leading coefficient of these two terms. So my horizontal asymptote is just going to be y equals 1. Okay, so let's keep going with this and let's find intercepts. So I'll clear some space. And so to find the y-intercept, I'm just going to plug in 0. So you might be saying, well, which function do I plug 0 into? Into this one or into this one? So you can plug 0 into whichever function would be easier for you to calculate because these two functions are equal to one another, so you're allowed to choose the one that's easiest. And I think it's easier to plug 0 into this function here because then I'm going to get 0 plus 0 plus 4 on top, and in the bottom I'll get 0 plus 0 minus 3. So this is the point 0, -4/3, okay? And then, so remember to find the x-intercept, you set the top of the function equal to 0. And again, it comes down to, I could take this top or I could take this top. They are equivalent to one another, so I'm just going to use x plus 2 squared equals 0. I'm going to use that form of the function. And so then I can pretty easily see that this will equal 0 when x is equal to -2. So this is the point -2, 0. Okay. The next thing that you have to do is to determine if the function will cross the graph at any non-vertical intercepts. So let's go ahead and do that. So our non-vertical asymptote was y equals 1. So what I'm going to do is I'm going to take the whole function and I'm going to set it equal x squared plus 2x minus 3. I'm going to set this equal to 1. Okay, and so now to solve this, so the first thing that I've got to do is I've got to multiply both sides by the denominator, really. So what this is going to give me then is x squared plus 4x plus 4 equals x squared plus 2x minus 1. So notice I just dropped the 1 because multiplying 1 by this will just give me the same function, so I can do that. Okay, so the next thing that I'm going to do then is I'm just going to try to solve this. So since everything's squared, first I'm going to subtract off the x squareds. And you'll notice the x squareds drop out. And then let's subtract off, actually let's just look at where we're at right now. So I've got 4x plus 4 equals 2x minus 3. So now I have an equation that's just in terms of x's, so I can solve this. So what I'm going to do is I'm going to subtract off the x's to one side, and I'll subtract the 4 to the other side. So I get 2x, 2x equals -7. So let me clear some space. Okay, and so now if I divide by 2, I get x equals -7, or so -7/2. So the fact that a solution exists, when a solution exists, this is the point, this is the x part of where the graph will cross the asymptote. So yes, it will cross at, so to determine that, you use the solution and that intercept. So this will cross at -7/2 and 1. So I need that point. Okay, so now we have enough here to graph. So let's make some space. Okay, so I've got my graph and I've got all my relevant information over here. So I'm gonna go ahead and mark my asymptotes first. So I have the asymptote at x equals 1 right here. I have the other one at x equals -3. I have my asymptote at y equals 1. And then I'm going to mark my intercepts. So I have 0, -4/3. So that'll be somewhere around here. -2, 0 right here. And then I also have this -7/2, which is equivalent to -3.5 and 1. So let's see, -3.5 and 1 is right here. So let me clear some space now and let's see if we can finish this. Okay, so I need a few more points here because this graph is doing something. It seems like kind of an odd graph. When in doubt, just plot a few more points. Okay, so here, so I know that this side of the graph needs to cut through the asymptote. So let's see, let's choose the point. This was -3.5, so why don't we just plug in -3? So if I take f of -3 and I just plug it into this function, or wait, -3 won't work, sorry, that's my asymptote, I meant -4. -4, this will give me 0.8, so I'll have this point. So let's see, -4 and 0.8 is around here. Okay, and why don't I just do, I'm going to do one more because I'm like super nervous about this. So I'm going to plug in -6, and that's going to give me 0.57. So that's the point -6 and 0.57. So -6 and 0.57 is like around here. Okay, and then I need one graph. So I've got now points on this side. I've got points within these asymptotes. Now something to remember here, this is where the graph crosses the asymptote. So in this little part here, you can't have it going through the asymptote, right? Because we don't have a point in this interval that will cross the horizontal asymptote. That point where it crosses the horizontal asymptote only happens right here. Okay, so in this last interval, I need to find just a point. So let's see, let's calculate f of 2. Oops, I'll take f of 2. So plug f of 2 into my function. I will get 0.22. Or sorry, I meant 3.2. Okay, 3.2. So 2, 3.2, somewhere up here. Oops, and I'll do a green dot again. And my pen's not working. Okay, right there. Okay, so now let's graph this. All right, so I think the hardest thing to think through with this one, that this is like a little subtle, but what do I do with this part here? Does this go past the y-axis, or does the y-axis act as an asymptote, or what's going on with this? Okay, so think about this. If I plug anything more negative in here, so -100, -7,000, whatever, the top will be what? The top will be positive or negative? Top's always going to be positive, right? Because we're squaring it. Now, what about the bottom? The bottom, if I plug something like a -100 in, this will be negative, this will be negative. This will be a negative times a negative. This whole thing, when I plug in negative numbers, will always stay positive. You just kind of have to think about like what's happening with the signs here. There's not like a hard and fast rule for this. So in just thinking through this, when I draw this part of the graph, I don't want this to go negative. That's basically what I wanted to just take a second to think through. So we kind of have like this almost like unspoken asymptote that like we just logically had to think through for this part of the graph. And this is just totally like a situational thing. Okay, now for this part, so the hardest thing to do here is to stay within the confines of these asymptotes. I feel like sometimes when you see a graph set up like this, it's like you want to have it go through the middle. So not all rational functions are going to go through the middle. That's actually it. So it's got to stay within the confines because the only point that crosses the horizontal asymptote was here. And then finally for this last part of the graph, so now I can just stay within the confines of my asymptotes. So there you go. So that was kind of a tricky one in some ways. All right, so moving on to example B here. So we're going to have an oblique asymptote. So let's see if I go through and I do the work here. For my vertical asymptote, so I set the denominator equal to 0. I'm going to get that x equals 2 for my vertical asymptote. And then I just know that I have an oblique asymptote here because I've discussed this in some other videos. Oops. So I've discussed this in some other videos. So you have 1 degree higher than the denominator. So you can just tell from that you're going to have an oblique asymptote. And I like to use synthetic division because that's just what I've been doing throughout this series. You can use polynomial division to do this technically, but I've been teaching synthetic division, so we're going to use that. So I'll go ahead and set all that up. So let's see. So the interpretation here is that my oblique asymptote would be 2x plus 1. Cool. So now let's go ahead and find intercepts. So I'll clear some space. Okay, so if I plug 0 into this function, so this will give me 1 over negative 1/2. So this is 0 and negative 1/2. And then for the other one, so I'm going to set the top equal to 0. And I hope this factors. So let's see, 2x and x. So let's see, this would be -1 minus 1. It does factor. All right, it's our lucky day. So my x-intercepts then are 1/2 and 1. So my 2 points here are 1/2 and 0 and 1 and 0. So remember, you can set these factors equal to 0 and solve. That's how I got those values. Okay, so let's keep going. Now we need to determine if this crosses the oblique asymptote. So let's go ahead and make some space. So to do this, I need to set this rational function equal to my oblique asymptote. And now to solve this, I need to multiply both sides by x minus 2. And then I need to factor the right side. So I have 2x squared minus 3x plus 1 equals 2x squared. Let's see. 2x times negative 2 is negative 4x plus 1 is going to be negative 3x minus 2. And now looking at this, I see that the 2x squareds drop out. And if I try to add the 3x's to both sides, those drop out. So I'm just left with 1 equals negative 2. So when that happens, that doesn't make any sense. So we just know that it does not cross. Okay, so now we can make some space and we can graph. Okay, so there's my graph. There's all the previous information that we found. So let's go ahead now. So I have the asymptote x equals 2, so I can mark that. And then for the oblique asymptote, so you just graph this. So the y-intercept is 1, so I'll mark 1. The slope is 2, so I go up 2 over 1. And I just mark my oblique asymptote. Okay, so now I mark my points: 0, negative 1/2, 1/2, 0, and 1 and 0. So I've got 3 points all within this little part of the graph. So This is one side of the asymptote. I need to know what's going on this side of the asymptote, so I'll choose a point over here. Let's figure out what's going on at f of, how about 3? So if I plug 3 into the function, I get that this will equal 10, so I can mark the point 310. So I don't have quite enough space for that in my graph, so I'll just mark 310 somewhere up there. And I've really got enough now to go ahead and graph this, because this won't cross any of the asymptotes. Okay, so there's one part. There's the other part. And we're good to go. Okay, so if you found that helpful, consider liking the video or leaving a comment on it. And otherwise, I will talk to you guys in another video. Thanks for watching.